missing, please call him. Okay, our competition will begin soon. Okay, our staff will deliver the problem paper and do not open the envelopes until the competition begin. Okay, pay attention. Do not open the envelopes until the competition begin. Hello everyone, please take your seats. Hello everyone, please take your seats. Okay, welcome dear contestants. Welcome to the 2026 Universal Cup Final Challenge sponsored by Huawei. I'm Li Minzhen from Contest Management Department of Huawei. And I will tell you some brief introduce about this challenge problem. First, this challenge is based on the Hydra online judge. You can find the bookmark in the Firefox browser. And our contest will last 5 hours from 12:30 to 17:30. The CPU limit is 7 seconds. And the memory limit is, for this problem is 1 gigabyte. Of course, you can connect the internet. You can use the search engine to find the article, find the blog, find the templates, code to help you to complete the contest. But do not use any AI tool or use any social network tool, okay? And for the printer service, you can use the DOM judge as the morning you use. And the submit limit is that you can submit only once per 5 minutes. And the standing will frozen in the last hour. That means beginning the 16:30, the standing will frozen. And now is the prize for this challenge problem. For the gold medal, only one team, and you can get €8,000. And for the silver medal, we have 2 teams, and you can get €3,000 per team. And for the bronze medal, we have 4 teams. Each team will get €2,000. And we also provide 18 outstanding awards. Each person will get a Huawei watch. And the last is 18 honorable mention. Each person will get a ear set, yeah. The Huawei Breeze Buds 6. Okay, so anyone can get the prize, but if you need to get higher prize, you need to get more improves on this challenge problem. Okay, next, let's welcome the key member of our problem order teams, Jingjing, to give us a brief introduction of this challenge problem. Welcome, Jingjing.
So, hello everybody. So, welcome to Huawei Lianqiu Lake to attend this exciting UC Final Challenge. I'm going to introduce the background of this challenge problem for afternoon's session. So actually, this challenge is from real usage, the large online inference system. So as everybody know, currently the most customer have no idea about the AI training system, but everybody uses the online inference system every day. So this problem is actually model the large online inference system. So the contemporary large online inference system including 2 stages. So one is the prefill. In the prefill stage, the inference system will compute the KV cache in the batch way for the input request. And then in the second stage, which is decode stage, in the decode stage, the inference system will compute the token one by one. So after each token generation, the KV cache will also continually increase. So it's not, it's very common for a single request occupy almost several gigabytes GPU memories. So this is the two stages for the online inference system. And in this challenge, so we are going to resolve an online scheduling problem. So you can imagine, so lots of online the requests comes to the inference system simultaneously. So you are going to resolve how to schedule this, how to schedule the requests to minimize the time to generate the first token, and also use the GPU's memory more efficiently. So actually, so this is the problem. We have the input parameters. For the first input, for the first input parameter is the input token length for each request. And the second input parameter is the output token length for each request. For the simplicity, so we assume this value can be predicted exactly. And the third input parameter is the arrival time of each request. And then we have the memory capacity for each GPU. We assume there are k GPUs in the system, and the different GPU may have different memory capacities. And all requests are in the decode phase. The prefill phase is assumed to be already completed. And the request consumes no CPU memory until it is scheduled. And for the scheduling model, so we have two times. So one time is the step I, so this is for the scheduling time for each request. And we also have the AI. So AI is the arrival time for each request. So generally speaking, the SI will larger than the AI. And for each request, and so the finish time step is SI plus LO out minus 1. And for each request, at each time step, it occupies the memory is the L in plus T minus SI plus 1. So at any time step, the total memory used by the requests on a single GPU will not exceed the capacity of the GPU's memory. So this is the last constraint. And this is the objective function. So you are going to optimize. So the first item is the summation of SI minus AI. So this is the total latency over all requests. And the objective is to minimize the V. The V also contains two other items. The first term is the maximum of the throughput. So it is the last request, it is completed. And the second term in this formula represents the longest waiting time of all requests. So preventing requests from being starved for a long time. And we also have a baseline algorithm. So this is actually a very naive algorithm to resolve this problem. We sort the request according to its input length. And then we just find an available GPU and schedule this request to the available GPU. And based upon this baseline algorithm, so we got a solution for this challenge. And you are going to use your algorithm to resolve this challenge more efficiently. So your score is actually based upon this formula. So we use the baseline benchmark to minus your benchmark, and then divide the throughput of all requests. So if your score is greater than 1, then you are better than the baseline benchmark. The score will also determine your standing in this challenge. Okay, so this is the introduction for this problem.
Okay, thanks, Jingjing. And we are about 5 minutes before the competition begin. So just prepare. Make sure you can log in the online judge system, and you can open this. Make sure your computer can open it.
To the web search work. This applies to
No.
No, so-
Yeah, no any. Sorry.
We can't open the statement yet.
Ready?
Start coding.
You cannot open it.
Cannot, yeah? I'm just curious because not.
You cannot open the online judge.
I mean, can we currently open the statement, or can we start coding something? What is the current? What we're allowed to do right now?
Do not open the envelopes before the competition begin. The competition will begin at half past 12.
I just
Yeah.
see that something.
But you can open the online judge.
Okay.
Yeah. But do not open the envelope. Okay.
Not open the envelope and not start coding anything, right?
Yeah.
Cup Finals Challenge sponsored by Huawei. I'm calling from Universal Cup Organizing Committee, and I will be host today. In this live stream, we will talk about today's challenge, introduce teams in this year's finals, and also give you a preview of the upcoming online challenge. So before we get started, let me first introduce the two guests joining me in the studio today. First, we have Mr. Jing, who will walk through the background and design of today's challenge, and we also have Mr. Huawei, who will later preview the upcoming challenge. So, Mr. Jing, let's start with you. Could you briefly introduce yourself to our audience?
Okay, so hello everybody. So I'm Jing from Huawei Computing Product Line, software platform team. So I'm currently an architect for Huawei's computing product line. So this afternoon's session, so I'm going to introduce the background of the challenge problem.
Thank you, Mr. Jing. And Mr. Yu, could you also briefly introduce yourself to the audience?
Okay, hi everyone. I'm Huawei Kang, and I'm an engineer from AI Algorithm Department of Huawei Global Technical Service.
Great. Thank you both for joining us. So now let's begin with today's challenge itself. So Mr. Jing, could you tell us a bit about the background of problem statement and the main idea behind this? Thank you.
Okay. So actually, today's challenging problem is a problem for the large-scale online inference system. So as everybody know, the most customer of today's AI system have no idea about the AI training, but almost every customer will use AI system through the large online inference system. So this challenging problem is some kind of simplicity problem from the real world problem of the inference system. So actually, we model the online inference system with this simple problem, and we have some kind of input parameters to simulate the request. We have the arrival time and for each request, and we also have the schedule time for the request, and the minus between the schedule time and the arrival time is the latency for every input request. And so in today's session, the attendant team, we're trying to use their algorithm to minimize the latency for all of the input requests. And as well as the latency objective you are going to optimize, we are also challenging you to optimize the responsiveness of the input request, because we cannot let some single request to wait for a very long time. We are keep from starving the request. And we also challenge the team to enhance the throughput of all of the requests. You are trying to schedule as most of the requests to the GPU as possible. And at the same time, there are several memory constraints for the problem. At any single time step, the scheduled requests for any single GPU cannot exceed the GPU memory capacity. If you overload the GPU memory capacity, so you cannot just service this request well. And we also have a baseline algorithm to resolve this problem. So this is some kind of very naive algorithm. We just sort the input request according to their input length. And we also use some very simple algorithm, try to schedule the request to the GPU. And based upon this, we got a baseline benchmark for this problem. And the attendant team will try to use the advanced algorithm, more advanced algorithm to resolve this problem. They are trying to optimize the overall the latency for all of these requests, as well as they also need to optimize the time to the first token latency, and also to optimize the overall throughput for all of these requests. And based upon this, you are going to get a score of your solution for this challenging problem. Your score is just use the baseline, the benchmark to minus your benchmark, and then divide the the throughput of all of the requests. So the higher of your scores, and you will get more good standings for this challenge. Okay. So this is the general introduction for today's challenge problem.
Yeah. Thank you, Mr. Jing. That was a great introduction. And now let's turn to our teams. This year we have 23 teams attend the finals, and this year's field is exceptionally strong. We have past Universal Cup champions, ICPC World Finals medalists, IOI medalists, and many of the most exciting young talents in the community. So let me go through the teams one by one. So the first team, our first team is USA 1, a very famous team featuring with Andrew He, Kevin Sun, and Gennady Krotalkevich. So the tourists, they are the reigning champions of the 2025 Universal Cup Finals, and they also won the championship at 2024 Universal Cup Summer Summit. With one of the strongest lineup in the world, USA 1 enters today as one of the clear favorites. So now let's take a look on their on-site view. So as you can see, this is the USA 1 team they are discussing on today's challenge problem. Great. Then the next team is Homama OVO from Japan, with Riku Kawasaki, Masaki Nishimoto, and Yui Hosaka. So they won the bronze medal in the 2025 Universal Cup Finals and was also placed third in the 2024 Universal Cup Summer Summit. They bring tremendous experience from both international Olympiads and ICPC World Finals. So it's also a very strong team will compete for the championship. So let's take a look for their on-site view. Yep. It seems that they're also discussing on the problem, and yeah, they're trying to find some points maybe. Okay. Okay, so our third team is Polish Mafia with Wojciech Najara, Motis Radzaki, and Marcin Sawowicz. And they won the silver medal at the 2025 Universal Cup Finals and finished as runner-up at the 2024 Universal Cup Summer Summit. This is a team full of world champions and in-light finalists. Let's take a look at their on-site performance. Now let's welcome the team Transacted Lights with Xu Qiwen, Chen Nuo, and He Fanyou. So one of the contestants cannot arrive today, but he will show tomorrow. And this is a very strong young Chinese team, featuring several recent national gold medalists and one of the rising lineup to watch in this year's fields. Let's take a look for their on-site view. Okay, so they already start coding. So it seems they already have the idea to solve the problem. Great. The next team is Lumina with Zhu Yikai, Chen Xingyang, and Shen Ziyu. So this team is from also China and the Peking University. Their members include IOI and LOI medalists, and they have deeply Olympiad strengths with recent Universal Cup on-site experience. Let's take a look at their on-site view. Great. They also start working on implementation. Next, we have Yusupo from Japan with Kohei Marita, Takuto Shigomura, and Shogo Marai. And this is another highly experienced Japanese lineup, including ICPC World Finals medalists and some of the most familiar names in the community. Let's take a look at their on-site performance. Yeah, great. They also start doing implementation. The next team is Flammable Dumpster with Wu Lin, Zhu Pengrui, and Li Qingyang. This is a young Chinese team built on recent top-level performance at NOI Winter Camp of CCF and APIO. So let's also take a look at their on-site view. By the way, these three contestants are still in high school students, so yeah, they're very young talents. Yeah, and also they already start doing implementation. Great. The next team is Thinking with Fedor Romoshov, Alexei Mikhenko, and Jimran Abdulin. And they brought together SPC World Finals experience and multiple IOI medals, making them one of the most technically dangerous teams, also a strong team to compete for the championship. Let's take a look at their on-site view. Great. It seems that they are still trying to find some ideas to do implementation, but the time's still enough. And the next team is Japan 4063649161 with Royal Takahashi, Mosanori Oiwara, and Takuto Koriyama. So they finished 17th at the 2025 Universal Cup Finals and continue to represent the depths of the Japanese competitive programming scenes. Let's take a look at their on-site view. And the next team is Arwin and Aerogame with Ryuto Watanabe, Yuhin Arwin Liang, and Ashley Argon Kon. And this team combines talents from Japan, Hong Kong, and Singapore with strong IOI records and international content achievements across several regions. So let's take a look at their on-site views. Yeah, it seems they are still trying to figure out some workable ideas. Now we welcome next team, Tono-sama with Tashuhito Yamagata, Yasunori Kinoshita, and Kosuke Kinoshita. So this team includes ICPC World Finals medalists from Japan and remains one of the most experienced lineup in this competition. And let's take a look at their on-site performance. They also already start trying to do implementation. Looks like rest of two participants are discussing on ideas. Okay, next up is Almost Retired Deadline with Alaski, Danny Luke, and Oleg Morkov, Rif, and Yahor Dobovik. And this team finished 14th at the 2025 Universal Cup Finals and the 7th at the 2024 Universal Cup Summer Summit. And its members have a long record of success in SCPC and major international contests. So let's take a look at their on-site review. Yep, they already started doing implementation. Yep, great. The next team is We Play with Mud in the Northeast. We have Stanley Wei, Cheng Zerui, and He Zhongtian. This is a team with deep roots in both SCPC and Chinese Olympiad scenes. It brings a very interesting behalf of backgrounds of today's challenge. So let's take a look at their on-site view. Okay, our next team is Freak Plus, represented by Liu Hengxi. Although this is a one-person lineup, Liu Hengxi won the bronze medal in the 2025 Universal Cup Finals, so it's really strong. And it's also an extraordinary young talent with top results in NOI, APIO, and IOI level competitions. Let's take a look at his performance. Yeah, he's still thinking and haven't doing his implementation yet, but it's okay. Great. And the next team we have is Protiv Virtua. We have Igor Kolikov, Pavel Marvin, and Boris Minayev. Yep. And they won the silver medal at the 2025 Universal Cup Finals. with names are legendary in both ICPC and individual programming competitions. This is one of the most respected teams in this field, and let's take a look at their performance. Okay, it seems they also haven't started doing implementation yet. Oh, looks like they already started trying. Yeah, maybe are doing some debugging. Okay, and the next team we have Afterlife with Peng Bo, Yan Zixuan, and Zhang Qiuyang. So they are from Zhejiang University, China, and won the championship at the 2024 ICPC EC Finals. East Asia Regional Contest, and they represent another very young, strong team from Zhejiang University. Let's take a look at their on-site performance. Great. It seems they are still discussing on the problem. Yep. The next team we have is Polar Bear Transform with Maxim Trorsky, Fedor Okshakov, and also Leonid Danilevich. They are champions of the 2025 ICPC World Finals, which alone makes them one of the most closely watched teams in the contest. And let's take a look at their on-site view. Okay, the next team we have is when Anton saw this team, he reacted with a very face. So, this team is consisted from Anton Choiga, Tawin Ostolu, and Alexander Kolkov. This is a very international team and includes several contributors from the community, and it also includes several experience from ICPC, IOI, and major global individual competitions. Let's take a look at their performance. Yep, it seems that they already started implementation and also may have some coming ideas. Great. The next team we have is Absolute Advantage from Chou Po-yu, Tseng Xing-yang, and Tsai Bring. So this team comes from a strong competitive programming backgrounds, and its members include ICPC World Finals medalists. Let's take a look at their on-site view. Great. Now welcome the next team, Ngam Gun, with Shengheng Zhou, Jaehyun Ku, and Michen Zhang. So this is star-studded crane lineup with LI medals, ICPC World Finals experience, and strong results in the contests like individual contests like CodeJam, Hacker Cup, and Yandas Cup. Let's take a look at their on-site view. It seems that they already make some submission trying to check the results. Yeah, hope they have some upcoming ideas. Great. The next team is Captain Take Me Not with Fang Xintong, Zheng Jun, and Jiang Chengyou. So they won the silver medal at the 2025 ICPC contest and the bronze medal in the East Asia Championship finals. So making them one of the very experienced team. And let's take a look at their performance in the on-site views. Yeah. Looks like they have some ideas when thinking on how to do implementation. Great. And the next team we have is Amstel Park with Pavel Koyavsky and Artem Vasilyev and Mikhail Alpatov. And they finished the 19th of the 2025 Universal Cup Finals and the 5th at the 2024 Universal Cup Summer Summit. They also include multiple IOI and ICPC World Final medalists. Let's take a look at their on-site view. And finally, we have the team battle at DS with Fan Sizhe, Shi Haojia, and Wang Xianbang. So despite the playful team name, this is remarkable lineup, including the IOI 25 gold medalists and multiple top performance from both Olympiad, informatics, and mathematics. Let's take a look at their on-site view. Great. So that's all the teams we have for this year's finals, and we are very excited for their following performance in the following contests. Okay, so before we wrap up to the next session, I would like to have a quick preview of what's coming next. So in July, we will host a U-Cup online challenge sponsored by Huawei. It will be a 2-week marathon-style online challenge with generous rewards. And to give us a closer look at that event, we are very happy to have one of the experts from the problem author team with us today. So, Ms. Yao, please introduce the problem with us.
Hi everyone, I'm very glad to introduce the problem we wanted you to solve and why this task is important for future mobile networks. Okay, the core idea is simple, and we think future mobile network needs AI, but today, many network optimization tasks are still handled in a reactive, manual, and fragmented way. To move from traditional optimization to AI native networks, we need a model that can understand the wireless world. That is what we call the channel world model. In this competition, we focus on a clear and practical task, predicting signal level values. Give terrain information and base station parameters. Participants need to predict the signal levels at different locations. This task is simple to understand but difficult to solve well in real network environments. A good prediction model can help us understand coverage, weak signal areas, and network quality before problems happen. AI is becoming a key technology for building future mobile networks. The direction of future mobile network is becoming clear. AI is becoming a key technology for building the next generation wireless network. Jensen Huang mentioned that next generation wireless network will be revolutionary. And we have an unprecedented opportunity to ensure AI is woven in from the start. This is an important idea. It does not mean adding an AI tool after the network is already built. It means that AI should become part of the basic design of future networks. AI should support network planning, modeling, optimization, and operation from the beginning. Today, mobile networks are already very large and very complex. Every year, there are more than 1.6 million network faults handling cases. Every month, engineers spend more than 12 million working hours on VIP complaint handlings. Every day, the network produces around 15 PBs of logs. These numbers show strong reality. Network operation is already under huge pressure. It is difficult to manage such a complex system only with human experience, manual analysis, and traditional rule-based tools. At the same time, this network supports more than 100 billion RMBs of business values, serves more than 3 billion users, and brings more than 130 million kilowatt hours of energy saving value. So, the mobile network is not only a communication system, it is a major infrastructure for the digital economy. Because of the scale, even small improvement can create a very large value. This is why AI is no longer optional. It's becoming a necessary foundation for future mobile networks. Traditional network optimization remains reactive and fragmented. Now let us look at the current network optimization process. Today, network optimization still has 3 major problems. The first problem is a KPI-driven optimization. In traditional work, engineers often look at KPIs such as coverage rate, throughput, drop rate, and complaint rate. KPIs are useful, but KPIs are usually results. They tell us that a problem has happened. They do not always tell us why the problem happened. They also they cannot fully represent the real user experience. For example, a KPI may look acceptable at the cell value level, but some users in a street corner, inside a building, or behind a hill may still have poor signal. So KPI-driven optimization has a limitation. It can describe the result, but it cannot fully understand the wireless environment. The second problem is reactive response. Many network problems are handled after alarms, complaints, or faults appear. A user complains, a VIP user reports poor service, a fault ticket is created. Then engineers start to check logs, maps, parameters, and historical data. This process is slow and expensive. It depends heavily on expert experience. It also creates a lot of repeated work. In many cases, engineers are not solving a completely new problem. They are doing similar things again and again in different places. The third problem is localized optimization. Traditional optimization is often done for a local cell, a local area, or a single complaint case. Engineers adjust parameters, check neighbor cells, or analyze a small region. They can solve some short-term problems, but it is difficult to build a global understanding of the network. A local change may improve one area and hurt another area. A method working in one city may not work in another city. So we need a new foundation. We need to move from reactive optimization to predictive intelligence. We need to move from local analysis to global understanding. We need to move from human-driven experience to AI-assisted network intelligence. So our goal is to build a channel world model for network digital twins. A channel world model should help us understand how wireless signals are distributed in real environment. It should connect geography, terrain, base station parameters, and measured signal data. It should help us predict signal strength in places where we do not have enough measurements. For this competition, we make the task clear and accessible. So that is our challenge, channel world model, from sparse measurement to a robust AI-based channel world model. So the main task is predict ISRP values. ISRP means receive signal strength from a base station. In simple words, it tells us how strong the wireless signal is at a certain location. So this challenge is about helping AI understand why signals are strong in some place, but why they are weak in others. This task may sound simple at first, but in the real network environment, it is difficult. And there are three core difficulties. The first difficulty is sparse and noisy ISRP measurements. In the real world, ISRP measurements are unevenly distributed across a map. Some rows or areas may have many samples. Some areas may have very few samples. Some places may have no samples at all. This is very different from a clean laboratory dataset. A model cannot see every point in the map. It must learn from the limited observation and predict the missing areas. Also, ISRP measurements can be noisy. Different devices and measurement methods can significantly affect ISRP values. For example, different phones may report slightly different values. Different collection rules may produce different data. Outdoor and indoor conditions can also be very different. Some areas, terrains, and base station types may have too few samples in the dataset. This means the model has less chance to learn these cases. For you, the key challenge is not to train a model. The key challenge is to deal with the real-world data. So the first question is, how can we learn a reliable signal prediction model from a sparse and noisy ISRP measurement? The second difficulty is geography and network feature representation. ISRP is strongly affected by the environment. Complex terrain is a major factor affecting signal propagation. For example, mountains, hills, buildings, roads, and open areas can change how the signal spreads. A receiver behind a hill may have much weaker signal. A receiver in an open area may have stronger signal. Indoor and outdoor signals conditions can be very different. So, a map is not just a background image. The map contains important information for signal prediction. At the same time, base stations are also very different. Base stations can be deployed on poles or on rooftops. Some are pole-mounted base stations, some are rooftop base stations. Their location and configuration vary wildly. A base station has many engineering parameters. For example, its location, height, antenna direction, tilt, frequency, and power can all affect coverage. The same terrain may have different ISRP values if the base station is higher, lower, facing a different direction, or using a different configuration. So the second challenge is how to turn geography and engineering data into useful model features. Participants should think about the distance. The third difficulty is the most important one. The goal is not to let AI memorize samples. The goal is to let AI learn the physical logic of wireless propagation. A model may get low error by memorizing local signal patterns. For example, it may learn that some training points have strong signal and some training points have weak signal. But this is not enough. If a model only remembers local patterns, it may fail when it is used for a new base station, a new terrain, or an unseen area. True generalization requires more than memorization. The model should learn why the signal changes. It should learn that the signal usually becomes weaker as distance increases. It should learn that the terrain blockage can reduce the signal strength. It should learn that antenna direction affects coverage. It should learn that base station height and deployment type matter. This is why we say the task is more than a standard machine learning task. We want participants to move from pattern memorization to propagation understanding. Of course, you guys do not need to be experts in wireless communication. You don't need to learn a fully electromagnetic simulation system. But you should try to design models and features that respect the basic physical law of signal propagation. A good model should not work only well on familiar measurement points. It should give a robust prediction in new places. To summarize, this competition is about channel world model. The task is ISRP prediction from terrain and base station parameters. The deeper goal is to build a foundation for AI native mobile networks. Maxwell equations give us the physical laws of electromagnetism. A successful channel world model may give AI the ability to understand, predict, and optimize the wireless world. You can help build the next step towards AI native network intelligence. Thank you.
Yeah. Thank you very much, Mr. Yeo, for your introduction. And this brings us to the end of today's live stream for the 2026 Universal Cup Finals Challenge sponsored by Huawei. Thanks again to both of our guests and thank to everyone for watching. And please continue to follow the 2026 Universal Cup Finals and enjoy the rest of the events. Goodbye.